Hello everyone, this is Chemistry at Glance and my name is Aneta. Today I'm coming to you with another video for my latest series, Last Minute Revision. And this video will go into a playlist with all the organic compound equations you need to know for your exam. And we're starting with oxidation of alcohols. But before we go into the oxidation of these alcohols, you firstly have to know there are three types of alcohols. The first type of alcohol is a primary alcohol, and this is an alcohol where the OH group is connected to carbon, which is bonded to only one other carbon, or if the OH group, so our alcohol group, is connected to a carbon which is bonded to no other carbons. This is the primary alcohol. Then we have a secondary alcohol. Secondary alcohol is an alcohol where the OH group, all these mean there are hydrogens around. So in a secondary alcohol, the OH group is connected to a carbon which is bonded to two other carbons. As the name suggests, secondary connected to two others, primary to one other, no other carbon. And lastly we have a tertiary, and as you probably know, that's going to be carbon, the OH group, which is connected to carbon, which is then bonded to three other carbons. That's the three types of alcohols that you need to know for your exam. And now let's go into the oxidation of these alcohols. We can't oxidize every alcohol from here. We can oxidize the primary alcohol, we can oxidize the secondary alcohol, however, we can't oxidize the tertiary alcohol. And what this means, I'm going to show you right now. So let's start with the primary. In order to oxidize an alcohol, we need an oxidizing agent. And this oxidizing agent we write as an O in square brackets. And it's called acidified potassium dichromate. This oxidation agent is good for all the alcohols that can be oxidized, so primary and secondary. This is always going to be the oxidizing agent. And another thing that you always have to do is a reflux, continuous condensation and evaporation. But that's only going to be needed in the primary alcohols. Okay, so let's show you the equations and then everything will be very clear. So, the primary alcohol. We have our ethanol, all the hydrogens around. Then, in order to oxidize it, we add the oxidizing agent, and what you get is an aldehyde. Plus H2O, of course, because we're missing the OH, the two H's. Another O comes in as in the oxidizing agent, so that's where we get the H2O from. This is an aldehyde. So if you oxidize a primary alcohol, you get an aldehyde. However, there's also a second step that can be taken if you use reflux. So we use reflux for primary alcohols because apart from aldehyde, if we take this aldehyde and we oxidize it even further, we get a carboxylic acid. First step, you get an aldehyde. Second step, you get a carboxylic acid. This time we don't need the H2O because we just added one more oxygen which goes around here, as you can see. So reflux is needed in this situation because if you use reflux, after you form your aldehyde, the products will continually condensate and evaporate. Therefore, the reaction can be done further. If we didn't have reflux and we formed aldehyde, aldehyde would evaporate. We wouldn't have the aldehyde to then oxidize again to form a carboxylic acid. So if you want to form a carboxylic acid, you have to use reflux. O that we have here is always acidified potassium dichromate. There will also be a color change visible, and this color change is orange to green. This is the color change visible when you oxidize an alcohol, either primary alcohol or secondary alcohol. Okay, so we now know how to oxidize a primary alcohol. We know a primary alcohol goes into aldehyde and then it goes into a carboxylic acid. However, with secondary alcohol, this looks slightly different. Okay, so the secondary alcohol that I showed you here is a 2-propanol. Okay, so we're going to use this one in our example. 3 carbons, the OH group is in the middle, then you have H's all around our hydrogens. Again, oxidizing agent is the same, acidified potassium dichromate, and this gets turned into a ketone. And of course, water in order to balance this equation. So this time we have a secondary alcohol and we have a ketone. We don't really need reflux here because it won't go any further. We can't change this into a carboxylic acid. We can't change this into anything else. It's just going to be a ketone. Our last type of alcohol, which I told you won't do oxidation. Tertiary alcohols are going to show no reaction with our oxidizing agent, acidified potassium dichromate. Okay everybody, that was all about the oxidation of alcohols for today. If you want to know more details, I'll always link the post on my blog to each topic. So if I talked about alcohols today, you're going to have a link to my post on alcohols in the description box below. So go and visit that if you didn't quite understand the video, if you thought you were missing something, go and check this out. After you're confident with the topic and you want to try some past paper questions, I also have on this channel video with past paper questions on just this topic on alcohols. Okay, for now, like, subscribe, share with your friends, your family, and see you soon. Bye!